Okay, so the next question I want to do is a very short, easy question. The reason I want to do this question is because it shows you, again, just the first law of thermodynamics and its significance. So it's question 4.16. A rigid vessel containing a fluid is stirred with a paddle wheel. The work input to the paddle wheel is 5,100 kilojoules, and the amount of heat removed from the tank is 1,600 kilojoules. Consider the tank and the fluid inside as a control surface and determine the change in internal energy of the control mass. Okay, so we have some tank, we have some fluid in the tank, and we have a work input. So it is a rigid tank, but the reason we have a work input is because inside the tank, connected inside the tank, is some kind of like motor or paddle wheel. And as we rotate this, we're adding energy to the fluid, right? So maybe it's some electric motor, it comes in as electrical energy, but then, you know, gets converted into some form of energy inside the tank, okay? So we also are told that heat is being removed from the tank. We're told, thankfully, how much. And just like we're told how much work is being input, we have work in, we have Q out. Now, first law of thermodynamics is what? Q minus W equals the change in energy. Okay, so like last time, do we have a change in potential energy? No. Do we have a change in kinetic energy? No. So the only thing we can have is a change in internal energy, right? Per unit mass, of course. So if we do this, Q minus W is equal to M times the change in internal energy, U2 minus U1. So by moving this paddle and by extracting heat, we are changing the internal energy. And the question asks, by how much? Now, I don't remember if they give us any information about the mass. No, they don't. So we'll have to do it per unit mass here. So what we'll do is we'll express it as Q minus small w, that's supposed to be, is U2 minus U1. So the answer we're going to get is, well, what we'll do actually is we'll assume, sorry, let's do it differently. Let's just assume the mass there is 1 kilogram, okay? Let's just assume the mass is 1 kilogram. So M is just 1, and we have U2 minus U1. Okay, so we are told that the amount of heat, sorry, let's start with the energy first. We're doing work on the system at a rate of at an amount of 1,600 kilojoules. And whenever we're doing work to the system, we always consider that negative by convention, okay? So if it's minus W, it's really minus W, which W is 1,600 kilojoules. All right, now let's talk about heat, okay? So we're told that heat is being given off by the system. It's losing that energy in terms of heat. So by convention, we say that that's negative, all right? So, sorry, I flipped the values around, excuse me. Let me redo this. So we're losing heat at a rate of 1,600 kilojoules. So we have minus 1,600, and then we do minus W. But like we said, because we're doing work to the system, W happens to be negative. So it's negative 5,100 equals the difference in internal energy. Okay, so of course, just basic math here. All right, and that gives you a change in internal energy of 3,500 kilojoules if you have 1 kilogram of mass inside the system, okay? And in terms of per kilogram, if you had a different mass, you could just do this in terms of per kilogram and work it out that way. But in this case, if you have 1 unit mass inside, the total change in energy is 3,500 kilojoules.